I was going to talk about how to solve slightly more difficult trig equations, or trig equations that take a little more effort. Now we're going to start you with a couple of easy ones here on the first screen, just reminding ourselves of a couple of things. Values like 1 or root 2 over 2 can easily be found using a unit circle idea when we're trying to solve trig equations. The sign is kind of like a y value, right, on a unit circle, and the only place on our unit circle, right, that the sign or the y value would be equal to 1 would be all the way up top here, or basically very simply at pi over 2, or at 90 degrees, right, at approximately 90 degrees. Everywhere else we would have been less than 1, but again at pi over 2 we get that value. Now what we want to notice though about our directions is it didn't say we only wanted to be from 0 to 2 pi right now. We only wanted the first full circle. We do want the exact value, so notice I didn't give a rounded decimal. But again, it never said anything, right? Never said anything about only going one circle. Remember that if we graph the sign, right, down here at the bottom, I've already got it pre-graphed for you, that the sine of x is equal to 1 multiple times over if we just keep going around the circle, right? Our first full circle would be the first period or first phase, but then it repeats itself, and it repeats itself. And remember that the period of the sine is 2 pi. So from the first time at pi over 2 to the next time and the time after that, all of our answers are going to be approximately 2 pi units apart. And what we call that, if we can write out the final answer, is a general solution. Now, I don't want to sit here listing off and listing off and listing off answers, because again, I would have to say pi over 2, and then I could say 5 pi over 2, right? 4 pi over 2 away, or 2 pi units away, right? 2 pi, same thing as 4 pi divided by 2. And I could say 9 pi over 2, and dot, 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 go onward and onward and onward. Or I could have backed up, right? I could have gone into the negative values, right, the other way. To write what we call a general solution, what we're going to do is take our first answer, so pi over 2, and I'm just going to say that all other answers are exactly 2 pi units away. So if I added 2 pi, I should get another solution. And if I add 2 pi times n, 1 or 2 or 3, n being an integer, I'm just adding full circles, right? As long as n over here, and sorry about the bad handwriting there, as long as n is an integer, I'm either going forward or backward one full circle. So pi over 2 plus 2 pi n would be what we call the general solution. Now, do we always use 2 pi? No, it depends on which kind of trig function we're looking at and how our function relates. Cosine of pi is equal to root 2 over 2 at 45 degrees and at 7 pi over 3, right, down here. Or sorry, 7 pi over 4 down here. So pi over 4 and 7 pi over 4. So this time what I'm going to want to do is say my first answer plus the period of the cosine, so again 2 pi n, over and over and over, or because the distance between these two angles and the distance all the way around here, if I'm going around and around my circle, I'm traveling a short distance to get from 7 pi over 4 to pi over 4, but then I'm going a long distance, right, to go back around. So I can't write them as a single statement. I'm going to have to add on another general statement. But all possible answers to my equation would come from those two general statements put together. Again, that's what we call a general solution. So if we're solving larger, more difficult equations here, right, let's go ahead and take a look at a couple of these and see what we can do. First thing I would notice is I have a tangent of x on both sides. So I'm going to go ahead and add tan x, right, to both sides. So this is going to become 3 the tangent of x plus root 3. And again, tan x, negative tan x plus tan x is really just equal to 0. If I subtract my root 3, and then I'm going to go ahead and divide that other 3 over, we'll notice that tangent of x is equal to negative root 3 over 3. And in that case, again, I'd want to think about my unit circle. Negative root 3 over 3 reminds me of the old negative 1 over root 3, right? If I was rationalizing or unrationalizing, derationalizing that, which means that the tangent, the opposite over the adjacent, my opposite needs to be negative 1. Tangent's negative down here in quadrant 3 and up in quadrant, or sorry, 4 in quadrant 2. But again, being negative 1 here with a root 3 adjacent, right? The longer side there. Which just leads me to believe if this is the short side, right, here of 1, and the long side down here of root 3, that this is a 30-degree angle. Right? Or essentially, x will be equal to 5 pi over 6, or, again, if we go all the way around down into quadrant 4, this would be 11 pi over 6. Again, you can verify those by plugging those into our equation. But what I want is a general solution down here at the bottom. Again, this would be from 0 to 2 pi. There are my only two solutions. But notice now, because they're a perfect half circle away from each other, when I write the general solution, really if I start at 5 pi over 6 and I add pi, that'll get me to 11 pi over 6. And if I add another pi, it would take me right back up into quadrant 2, another pi down into quadrant 4, and the general solution actually sort of has a shortcut. The same thing can be said about the equation at the right here. If I factor out a cosine, and notice there's a cosine in both parts there, I can get myself two separate statements. Again, two things multiplied equal to 0. The basic idea of factoring, either the cosine of x then could equal 0, or 2, the sine of x minus 1 equals 0. Cosine of x is going to equal 0 in two different places. Cosine equals 0 up here at pi over 2, and down here at 3 pi over 2. So again, I can say pi over 2 or 3 pi over 2 are a couple of good answers there. But my equation at the right here, I need to add 1 and divide by 2. The sine of x equals 1/2, well, also in two places, up at pi over 6 and 5 pi over 6. So there would be my two answers in that first full circle there. The general solution, well, I kind of want to draw one simple picture. I've got one answer directly up and directly down, but then I have answers over here and over here as well. So now you'll notice the answers from the first one, the cosine of x equals 0, well, I can kind of shortcut that one. Pi over 2 plus, again, pi n. They're directly across from each other. But the quadrant 1 and quadrant 2 answers, again, are going to have to be written separately. Pi over 6 plus 2 pi n, or 5 pi over 6. I think I'm getting a little low on my screen here, so let's go ahead and put my or over here. 5 pi over 6 plus 2 pi n. And sorry about the bad handwriting there. But again, I'm going to need all of those possible answers to get that right. So hopefully those answers make sense to you. Again, if you have any questions about solving these equations, I'll have a couple more videos with a couple more, maybe more difficult examples. Also talking about what happens when there's a looping example, and you'll see what those are. So don't be afraid to watch some more videos. Otherwise, have a great day.